So these top two, I want you to compare. The top two were the ones that we just did. And then we have these two other examples. And when you compare them, the big difference is you now have two trig functions in your integral. And so the question that immediately sort of arises is, well, is this an integral about sine, or is it an integral about cosine? And the big clue is, which one has the exponent? We have sine x cosine squared x, sine x 4 minus cosine x all to the fifth. It's the cosine that has the exponent, and that's what gives me the clue that that is what the integral is about. So, if I now look at it individually, my u here is the cosine of x. And again, this, you can think of it as sine x cosine x squared dx. And so it's the cosine function that is my u. And when I think of that, I have u as cosine x du, and I put the derivatives back up again, because the derivative of cosine x is negative sine x. And so that's why our integral have the two functions, cosine and sine, because you have cosine raised to a power, so you're going to be needing the derivative of it. It's, again, the product, or the chain rule. You have a function inside something to the second power. I need negative sine x, so, or actually I need it positive sine x, so I'm going to multiply this by negative 1. So I have negative du is the sine equal to sine x dx. And now my integral, again, realizing the cosine of x is u, this is really the negative, because of the du, u squared du. So at the moment, it's no longer a trig integral, but it's just a normal integral of add 1, divide by the exponent, we still have the negative, and plus c, where u happens to be the cosine of x. So, when you first start off looking at this integral with the two trig functions, it's kind of natural to think, am I taking the integral of the sine function or the integral of the cosine? Because cosine's raised to an exponent, it's actually the function inside the function. The sine happens to be the derivative of the function. And we're thinking of substitution, where we're actually substituting and replacing our trig function just for u, coming up with a much nicer integral, something that we've done in the past before, and integrate and resubstitute.